Welcome to this lecture on work, energy and power. In this lecture, we will talk about mechanical energy which exists in the form of potential energy and kinetic energy for an object falling or rising in presence of gravitational field. यहाँ इस लेक्चर के बाद हम एक टर्म इंट्रोड्यूस करेंगे. दैट टर्म इज कि व्हाट इज ए कंजर्वेटिव फोर्स फील्ड. ग्रेविटेशनल फील्ड के बारे में आपको पता है कि अगर हम एक ऑब्जेक्ट लेते हैं हुज मास इज कैपिटल एम, उसके नजदीक एक और ऑब्जेक्ट रखते हैं जिसका मास स्मॉल एम है, उनके बीच में अगर डिस्टेंस है आर और ये यूनिवर्सल ग्रेविटेशन कांस्टेंट है, सो ये इक्वेशन जो हम देख रहे हैं G into m divided by r square, we call it as Newton's law of gravitation. So this is Newton's law of gravitation, which says that there will be a force of attraction between two objects, which will be given by G into m by r square. इस लॉ को अगर हम अप्लाई करें टू अर्थ सरफेस, तो मान लें ये है हमारा अर्थ का स्फीयर whose radius I take as r, this is the radius r, ये इसका सेंटर है, और यहां पर हमने एक ऑब्जेक्ट फॉल किया है which is lying near the surface of earth. इस ऑब्जेक्ट का मास है स्मॉल m, अर्थ का मास है कैपिटल M. Then this object will be acted upon by a force given by F equal to G into m by r square. We are assuming कि जो ये ऑब्जेक्ट की हाइट है, this height it is negligible. That means ये जो हाइट है it is very very small as compared to Earth's radius. Otherwise, यहाँ denominator में r plus h whole square होना चाहिए. So since h is very small as compared to r, उसको हमने यहाँ ignore किया for y. अब ये जो relation है, this relation tells us कि there will be an acceleration which this object will show. That acceleration is force acting per unit mass. So this is force acting per unit mass which will be given by g into m by r square. So this is a constant whose value is, जो g की value है, it is 6.67 into 10 raised power minus 11 Newton meter square per kg square. Then we have the mass of earth, which is again a constant. We have radius of earth 6400 kilometers, which is again a constant. We are assuming the height of object very small as compared to the size of earth, and the mass of earth is 6 into 10 raised power 24 kg. So if I give the values to g 6.67 into 10 raised power minus 11 Newton meter square per kg square, then I give a value to mass which is 6 into 10 raised power 24 kg. We give a value to radius of earth which is 6400 kilometer. हम इसका एवरेज रेडियस ले रहे हैं 6400 किलोमीटर, और this can be written as 6.4 into 10 raised power 6 meter. So इस values को substitute करके अगर हम यहाँ देखें, we obtain an acceleration which comes out to be, जो g की value यहाँ से आएगी, that comes out to be 9.8 meter per second square. Now assuming this value of g, हम देखते हैं कि जब भी हम अपने आसपास in our day to day life कोई भी ऑब्जेक्ट अर्थ के फील्ड के प्रेजेंस में ड्रॉप कर देते हैं, this object will fall down, its velocity will increase at the rate given by g, that is it will change every second, it will increase by 9.8 meter per second. Now think of the energy which is possessed by such an object. So assume कि ये हमारे पास earth है, that is the ground, earth surface. So this is ground. ये एक object है which is at a height h with respect to the ground. So this is height h. और इस object जिसको मैंने एक position a पर रखा हुआ है, इसका एक mass है, that mass is small m. Right now this object is at rest at height h, और at position a it is at rest. You understand कि जब हम अर्थ के प्रेजेंस या फोर्स की प्रेजेंस में इस ऑब्जेक्ट को रेस्ट में मानते हैं, सो एट पोजीशन ए द ऑब्जेक्ट इज एट ए रेस्ट. वी सी कि एट दिस पोजीशन इट हैज ए पोटेंशियल एनर्जी. दैट पोटेंशियल एनर्जी which it possesses at A is given by mgh. So this is simply the concept of work. So if we make the object to fall, you will get a work out of it. That work which was done initially by an external agent जिसने इस object को raise किया था from ground to this height h, that work came out to be the force into distance, and we are thinking of a constant force acting on the object because हम g को constant मान रहे हैं. In that sense, it comes out to be force into distance, that is mg into h. Now, if I further go that find out what is kinetic energy of the object at position A, my answer to this is 0 because the object is at rest. Or kinetic energy, you understand, is 1 by 2 mv square. Now what about the total energy? So if I say this is the total energy at A, I am referring to mechanical energy. मैं sound या heat या बाकी सब energies को exclude करके सिर्फ mechanical energy की बात कर रहा हूं, and that mechanical energy will be sum of potential energy and kinetic energy. So it is mgh plus 0, that is mgh. Now allow the object to fall. Let the object while falling down, ये एक position B को touch करता है in midway somewhere in air, so ये इसकी position B है. Say it has fallen from this height through a distance A, or what remains is that this distance will be equal to h minus A, or at the height h minus A, which we call as position B. So at position B, what is happening that the object has now a potential energy at position B, which will be mg into, so with respect to ground, iska height hai h minus A, that is h minus A. This I can write as mgh minus mga. So you see there is a decrease in its potential energy. जो potential energy mgh थी, now it has become mgh minus mga. But so on the other side, जैसे ये ऑब्जेक्ट यहाँ वेलोसिटी 0 से स्टार्ट करता है, ये एक वेलोसिटी v एक्वायर करता है यहाँ पर. So this increase in velocity can be found by using equations of motion. We are eligible to use equations of motion in this case because this motion is occurring under uniform acceleration. Or you remember one such equation which we say v square minus u square is equal to 2as. A here is acceleration. So I have v square, that means the final velocity at position B, which I can write as vb square minus जो initial velocity थी जब इसने A से start किया, which I call as va square is equal to 2 into what was the acceleration during this course. The acceleration during this course was g, and what was the distance traveled by this object during this course, that is A. So I substitute va equal to 0 and I obtain vb square is equal to 2 into g into A. Now this relation which says that vb square is equal to 2 into g into A can give us kinetic energy at position B. Kinetic energy we define as 1 by 2m into vb square. And vb square I put equal to 2ga, so I have 1 by 2m into 2ga. This 2 gets cancelled, we get mga as the kinetic energy at position B. Now if we find total energy at B, we can see that total energy at B will be the sum of potential energy and kinetic energy. So we calculate total energy at B comes out to be mga, this is kinetic energy at B, plus mgh. So this is mgh minus mga, ये हमने already calculate किया है. mga and mga gets cancelled, so we have mgh as the total energy at position B. What you realize कि जो total energy at A थी equal to mgh, वही total energy at B है mgh, जबकि at A and at B the potential energy and kinetic energy are different. So by this time we realize that there may be a variation in the amount of potential energy possessed by this body and the amount of kinetic energy possessed by this body, but that variation does not mean that total mechanical energy changes. The sum total of those potential energy and kinetic energy remains constant. This is what we will call as the conservation of mechanical energy in presence of gravitational force. We go to yet another case. Let's say कि अब ये ऑब्जेक्ट जो है ये ग्राउंड को हिट करने वाला है. So at the position just about to hit the ground, which I call as position C, let's find out again the potential energy and the kinetic energy at position C and see whether our this result remains true or not. So I have at position C potential energy at C. Now since the object is very very close to ground and is about to hit, we take it equal to 0. It's about to hit. अब इसे hit नहीं किया, it is just about to hit. और जो इसकी kinetic energy है, that kinetic energy I can say is 1 by 2 m vc square. V is the velocity which this object has acquired by falling down from the initial position to the position C. अब फिर से हम ये रिलेशन यूज कर सकते हैं, v square minus u square is equal to 2as. This time I choose the point A and the point C, so we write vc square minus va square is equal to 2 into g into, see, the distance covered from A to C is equal to h. You could have also used B and C. आप उससे भी इसको निकाल सकते हैं, but I am choosing A so that this becomes simple here क्योंकि VA की वैल्यू 0 है. So I write VC square minus 0 square is equal to 2GH. So I have a result VC square is equal to 2GH. Now I can substitute VC square here and calculate kinetic energy at position C, which comes out to be 1 by 2 into m into VC square. So VC square is equal to 2GH. So this is 2GH. Now if I cancel out 2, so we have cancellation of 2 means we get the kinetic energy at position C equal to mgh. We can now determine what will be the total mechanical energy at position C. So at C, the total mechanical energy at C would be given by potential energy at C plus kinetic energy at C, which comes out to be 0 plus mgh. So that is again equal to mgh. So what you have observed is that even though the kinetic energy and potential energy at point C are different than the kinetic energy and potential energy values at point A and point B, but the sum total of kinetic energy and potential energy remains same. And that sum total, which is equal to mgh, gives us the total mechanical energy of this system. And we say that in presence of gravitational force, the sum total of potential energy and potential energy and kinetic energy remains same, and that way we have come up with the law of conservation of mechanical energy. We can depict this whole situation by plotting a graph. The graph will be a curve which will be representing total mechanical energy, kinetic energy, and the potential energy. So imagine that this is the energy on the vertical axis. Here I see I have a straight line. This indicates that something remaining constant over the distance. So I am talking about the distance. And then there is the potential energy and the kinetic energy. So these two curves, they will be denoting kinetic energy and the potential energy. If you see that you are at the distance that is top, तो आप क्या कर रहे हैं? You are coming from top to bottom. या अगर हम bottom to top लें, that means if I take h equal to 0, ये h की value है. So if I take h equal to 0, you are on the ground. On the ground, what is happening? Kinetic energy is maximum and potential energy is 0. So this curve is kinetic energy and this curve gives potential energy. Now from ground, you go to height h. So as you start from ground to height h, the potential energy goes on increasing till the time, ये जो point है, here you are at height h, that means here you are at position A. तो ये मान लें आप, ये है पोजीशन C और ये है पोजीशन A. So at position A, you see that what is going to happen is कि पोटेंशियल एनर्जी इंक्रीज होके mgh के बराबर हो जाएगी और जो काइनेटिक एनर्जी C पर मैक्सिमम थी ये आस्ता आस्ता वहां जीरो हो जाएगी at this position. और यहां पर कहीं there will be some position where the kinetic energy and potential energy can become equal also to each other. So you can pose a simple problem. आपको पोज किया जा सकता है कि why, where, at what distance away from ground will the kinetic energy and potential energy become equal to each other. Very simple to determine. अगर मैं उस पोजीशन को कोई डिस्टेंस x मानता हूं, so at that height what will be the potential energy? It will be mgx. जैसे अभी हमने a पर निकाला है काइनेटिक एनर्जी, तो आप उससे इसी तरह से x डिस्टेंस पर उसका वेलोसिटी निकाल सकते हैं ऑब्जेक्ट का by using the relation v square minus u square is equal to 2s. इक्वेट द टू तो आपको x की वैल्यू मिल जाएगी. अगर मैं कहूं कि where is the position where kinetic energy is twice the potential energy, सेम फॉर्मलिज्म, उसमें जो काइनेटिक एनर्जी है उसको आप ट्वाइस पोटेंशियल एनर्जी कर दीजिए, assume a distance x और determine the value. Now this whole red dotted line is the indicator of mechanical energy, which is sum total of the potential and kinetic energy. Or you see that over the whole distance, as the object was going either up or down during the course of its journey, the mechanical energy remained constant. It did not vary even though the kinetic energy and potential energy changed. अब देखिए, जब ये ऑब्जेक्ट फॉल करता है और ग्राउंड को हिट करता है, जो इसकी मैकेनिकल एनर्जी है वो ट्रांसफॉर्म हो जाती है. It may turn into sound, it may turn into some sparking or light, it may turn into heat. So don't think कि वहां पर वायलेशन हुई है. Now we come from mechanical to the total energy. So since the heat appears, sound appears, light appears, so at the end of its journey, the mechanical energy which was preserved in it or which was present in it may be converted to other forms of energy, so that law of conservation of total energy will also remain true. So law of conservation of total energy says that we can neither create energy nor destroy energy. हाँ, ये हो सकता है कि mechanical energy can be transformed into heat or light or sound. That is permissible in nature. So in that sense, we can think of other forms of energy coming up. या एक और सिचुएशन है जिसमें जब हम एयर रेजिस्टेंस को कंसिडर करते हैं, when object started off from the position A like this, while falling through the air, it lost some energy to air because of the air resistance. वो भी आपको उसका अकाउंट भी लेना होगा. So that will again come under the head law of conservation of total energy. उसमें हम देखेंगे कि जो during the course of fall energy loss हुआ है, that will have to be subtracted from its initial energy. So that lesser amount or the total energy less by that amount will be the energy with which it will hit the ground. So this was about the mechanical energy. We now come to the concept of a conservative force field. अब इस चीज को हम थोड़ा मॉडिफाई करके देखें. Let's modify this diagram. जिस डायग्राम में हमने एक ऑब्जेक्ट को अलाउ किया that this is an object of mass m, we permitted it to fall down directly to the ground और हमने एक स्ट्रेट लाइन पाथ के थ्रू इसको नीचे आने की इजाजत दी. What we see is कि जो इसमें लॉस ऑफ पोटेंशियल एनर्जी है, that loss of potential energy is equal to mgh. इस लॉस ऑफ पोटेंशियल एनर्जी को मैं वर्क के साथ कंपेयर कर सकता हूं. दैट मीन्स इन दिस केस द वर्क इज डन बाय द ऑब्जेक्ट एंड दैट वर्क डन इज इक्वल टू mgh. मैं ऐसे भी कह सकता हूं कि ये ऑब्जेक्ट किसी एक एक्सटर्नल एजेंट ने रेज किया था फ्रॉम द ग्राउंड और उसको इस हाइट h पर पहुंचा दिया था. सो जिसने इसको रेज किया, he did the work equal to mgh on the object. So this is about the initial part. अब हम ऐसा करते हैं कि let's make this object to fall to the ground not along the straight line path, along this path. And our question is, during the fall along this path, is the work done equal to the previous value or not? Now once you think about it, you have to understand कि जो वर्क है, that work is the dot product of force and displacement. तो आप जब इस पर सोचेंगे I will suggest that how you do it. आप ऐसा करें कि इस पाथ को हम छोटे छोटे पीसेस में ऐसे डिवाइड कर देंगे, like this. So I am doing it now in the piecemeals. We are trying to find out that what would be the work done. When you take the horizontal part of this path, ये देखिए ये पाथ अब मैंने इसको पीसेस में डिवाइड किया है. Along the horizontal path, यहां से लेके यहां तक ये एक horizontal path है. You will see कि force of gravity ऐसे एक्ट कर रहा है. This is the force of gravity और the displacement is horizontal. Now assuming कि जो work है, that work is the dot product of force and displacement, what would happen is कि along this path, when displacement is perpendicular to the force, work done would be zero. मैं वो pieces इस diagram में से cancel out कर देता हूं, along which the work done is zero. So I take off this one because along which the work done is zero. Then I take off this one along which the work done is zero. Then I take off this one, इसमें भी work done zero है. इसको भी मैं बाहर निकाल देता हूं, work done zero. What you are left with, इसको मैं बाहर निकाल देता हूं, work done is zero. यहां मैं इसको what you are left with, you are left with those segments. अब देखिए this plus this plus this plus this plus this. अगर आप इस सारे vertical pieces को add करेंगे, you will be finding that you are on this diagram like this. So we have added all these vertical pieces and we get the same distance. What does this show now? What it shows is कि जो ये vertical distances हैं, these are the only paths where work is done. So work done is not equal to zero, it is finite. Along the horizontal pieces, work done is zero. अब ये property work की definition में छुपी है. और if we see that this process proceeds through a height h, then we can say that net work done along this path, जिसको मैं path A, B कहता हूं, is equal to the work done along the path AC. I can now shift the position of C. अगर मैं ये कहूं, same formalism, यहां भी work done will be same as this one. अगर मैं इसको कहूं, this is again same, work done will be same as this one. So what I have a very important conclusion from this. The conclusion is that in the gravitational field or in the presence of gravitational force, the net work done between 2 points is path independent. So remember the term, it is path independent. Path independent means that you select the initial point, you select the final point, और आप initial to final किसी भी रास्ते से चले जाएं, work done will be same. This is a significant result of physics जो बाद में एडवांस थ्योरीज में एक बहुत ही इंपॉर्टेंट रिजल्ट है. बट राइट नाउ हम इस रिजल्ट को बहुत ही एक सिंपल एक्सप्लेनेशन से देखते हैं कि सिंस वर्क डन इज जीरो व्हेन फोर्स इज परपेंडिकुलर टू द डिस्प्लेसमेंट, तो अगर एक पाथ है, उस पाथ को हम हॉरिजॉन्टल वर्टिकल स्लाइसेस में बदल दें, देन वर्क डन विल बी देयर ओनली अलोंग द वर्टिकल स्लाइसेस, not the horizontal ones, so that net work done will become path independent. It will not depend on the shape of the path. It will depend only on the initial point and the final point. So from initial to final, in whatever manner you go, आप first रास्ता adopt करें, second रास्ता adopt करें, third adopt करें, fourth adopt करें, work done will remain same. Now there is something more to it कि अगर हम ऐसा करते हैं that I first bring an object from A to B. So I have done a process of making the object to fall down. While it was falling down, it delivers energy to us. You can see a falling object, when it hits a surface, it can break the surface. That means it has delivered energy. Then I bring an agent to raise this object back to the same position. तो हमने अब ऐसा किया कि we have made the object to fall down from A, position A to C. C is on the ground, and back from C to A. Since I said that this net work done is independent of the path, I could have made it like this. इसको ऐसे कर सकता हूँ, from A to C along this path, and then from C to A to C, C to A along this path. So this is A to C and this is C to A. What you realize कि हमने अब gravitational force की presence में एक closed path define किया है. We have taken a closed path. This path started from A, touched C and came back to A. So it's a closed path. और इस क्लोज्ड पाथ को हमने एक खास डायरेक्शन में मूव किया है. दिस इज द डायरेक्शन. एंड यू रियलाइज कि अगर हम इनिशियली देखते हैं कि जो फोर्स है और डिस्प्लेसमेंट है, दे आर इन द सेम डायरेक्शन, और आई एम टेकिंग वर्क पॉजिटिव, इन द अपोजिट मैनर वर्क इज नेगेटिव. अगर ये पहले आती बार mgh है, जाती बार भी mgh है with a minus sign, so net work done along this closed path is 0. So net work done will be equal to 0. Now this net work done around the closed path equal to 0 is again a very important result, जो पिछले रिजल्ट के साथ जब हम कंबाइन करते हैं we come to a very important term. The term is conservative force. ऐसा फोर्स जिसमें ये दो प्रॉपर्टीज हों. एक प्रॉपर्टी कि नेट वर्क डन इज बिटवीन 2 पॉइंट्स इज independent of the path prescribed between these 2 points. That means the net work done is path independent. और दूसरा, that net work done is equal to 0 if we take a closed path. अब ये रिजल्ट कई फोर्सेस के प्रेजेंस में ट्रू रहता है और कई फोर्सेस की प्रेजेंस में ट्रू नहीं रहता है. जहां ये ट्रू रहे we call them conservative forces. आपके सामने ग्रेविटेशनल फोर्स है, इट्स एन एप्ट एग्जांपल ऑफ अ कंजर्वेटिव फोर्स. आप आगे बढ़ के इलेक्ट्रोस्टैटिक फोर्स की बात करेंगे, अगेन ए कंजर्वेटिव फोर्स. लेकिन कई फोर्सेस ऐसे हैं वेयर दिस डज नॉट हैपन. जैसे इफ आई टेक एन ऑब्जेक्ट एंड मूव इट ऑन अनदर सरफेस लाइक दिस, द मोमेंट आई एम मूविंग देयर इज सम लॉस ऑफ एनर्जी ऑफ दिस ऑब्जेक्ट which is happening while moving on the path because of friction. जितना मैं लंबा रास्ता इसमें लूं फ्रिक्शनल पाथ, उतना ही जो एनर्जी कन्वर्शन होगा, एनर्जी डिसिपेशन होगा, वो ज्यादा हो जाएगा. दैट मीन्स इफ आई टेक ए स्मॉल पाथ, then I take a large path in presence of friction, then I take a still large path, the net work done will not be equal to 0, because you are losing some energy to friction in the form of heat or some other form. Because of that, the total work done around the closed path will not be equal to 0. Also, if I take a shorter path between these 2 points, shorter path, then I take a longer path between the 2 points. What is going to happen is, for shorter path, the work done will be different from the work done between the same points. Points वही दो हैं, A और B. लेकिन I am taking a longer path, the work done will not be same. And most of these forces become the forces where there is irreversibility. That means you cannot recover the dissipated energy once it is given or once it is taken from the body. वो आप recover नहीं कर सकते. And in that sense, these forces become non-conservative forces. At times, we have a situation like this कि हमारे पास एक explosive है. The moment that explosive blasts off, इसकी फ्रेगमेंट्स हो जाती हैं, पीसेस हो जाते हैं. Was this a situation which we will deal with a conservative or a non-conservative force? इसमें भी आपको irreversibility दिखाई देगी. Once the explosion takes place, whatever chemical energy is lost is not recovered. वो जो बॉम्ब था या एक्सप्लोजिव था, वो फ्रेगमेंट से आके खुद नहीं बन पाएगा. So in that sense, we have to think that it was not a conservative, it was a non-conservative force. Now, does this discussion end only on the forces, or in physics it can be extended to something more than forces? The answer is that it can be extended to something more than forces. What is that? We talk of, in general, a conservative vector. What's a conservative vector? If I say that there is a vector A, which could be force also, this vector A shows a property that the dot product of this vector around a closed path. देखिए, इसको हम line integral कहते हैं. This is a length element, dr is a length element, और this circle indicates a closed path. This should be equal to 0. तो पहली property. दूसरी property, if we take the line integral of this vector A and around the path which is not closed but it is open, we started from some position, say R1, and stopped at some position, say R2, and this integral is path independent. Then if these two properties are present in a certain vector, this vector is a conservative vector. Why we generalize this? क्योंकि हम हर बार देखते हैं कि जो वेक्टर का डॉट प्रोडक्ट है डिस्प्लेसमेंट के साथ वो एक वर्क को रिप्रेजेंट नहीं करता है। हाँ, जब फोर्स की बात हो रही हो, then we call this as work done around the closed path is equal to 0 or work done on an open path, क्योंकि F dot dr will be a work done is path independent, लेकिन in general when we are dealing with a vector of any other nature other than force, it does not turn out to be work. और इस जनरलाइज रिजल्ट को आप याद रखें कि व्हाट इज अ कंजर्वेटिव वेक्टर? द कंजर्वेटिव वेक्टर इज दैट whose line integral around the closed path is equal to 0 or whose line integral on a path which is not closed but is open is path independent is the two results. अगर ये दो रिजल्ट्स एक वेक्टर फॉलो करता है, we call it as the conservative vector. Or you have kept in mind the examples of conservative and non-conservative forces. Air resistance and friction are two very common non-conservative force. Gravitational field, electrostatic field, which have the gravitational force and electrostatic force, are the conservative vector fields. In general, we can think of a conservative vector as anything which follows these two properties. So from this, we have taken some very important clues about the first. We have talked about mechanical energy, which exists as potential energy and kinetic energy. We have taken an object falling or rising in presence of gravitational field, determined its potential energy and kinetic energy at some of the positions. Then we found that sum total of potential energy and kinetic energy throughout the fall or throughout the rise remains same, which leads us to conservation of mechanical energy and also tells us that gravitational force is a conservative force. Then we talked about the conversion of that mechanical energy into heat and sound when the object hits the ground, which tells us that besides mechanical energy, there is also conservation of total energy. Total energy includes heat, sound, light, electric energy, magnetic energy, and others. Now we have to talk about what is a conservative force field and a non-conservative force field. You have seen how we determine two very important properties, that work done around the closed path is equal to 0. The net work done is path independent if we are talking about force. If we are not talking about force, we are talking about a general vector. Later on, you will see that electrostatic field has a vector called as electric field vector, which may come up. There, this dot product is not always work. It is said to be the dot product of vector, and we call this integral as line integral. If line integral around the closed path becomes equal to 0 and line integral on the open path between 2 points becomes path independent, it depends only on the coordinates of the initial point and the final point, and this property is, if obeyed, we say that the vector is a conservative vector. We realize now कि जो एक conservative force है, corresponding to a conservative force, there will be existence of a function जिसको हम उसका potential energy कहते हैं. जैसे we have gravitational potential, we have the electrostatic potential, लेकिन there is no such existence of a potential corresponding to a non-conservative force. आप कभी भी ये नहीं सुनेंगे कि there is something called as frictional potential. No. There is electrostatic potential or there is gravitational potential, but we cannot have a potential corresponding to the frictional force. तो ये जो प्रॉपर्टी है, ये इसी जो हमने ये लाइन इंटीग्रल दो सेट किए हैं, इन्हीं का आउटकम है, मैथमेटिकल आउटकम है कि corresponding to conservative force there is possibility of existence of a potential and therefore potential energy, whereas for non-conservative force there is no potential or potential energy.